Hi everybody, welcome to the topic of bioremediation of polluted environment by microorganisms. So, first of all, we will discuss what is the purpose of bioremediation because microorganisms are capable of biodegradation of xenobiotic or recalcitrant compounds. The reason is that the natural microbial community often will not be able to carry out their biodegradation processes at a desired rate due to limiting physical or nutritional factors. For example, biodegradation often will be limited by low oxygen levels, pH, etc. And also it is limited by the hydrocarbons, nitrogen, phosphorus and other nutrient substances may also be absent or available only at slow flux rate, thus limiting the rate of biodegradation by microorganisms. This is where we require the bioremediation approaches. Now we'll see what is bioremediation. Bioremediation is a group of treatment methods or processes designed to enhance the natural microbial degradation of organic contaminants. The microorganism carry out the degradation of harmful substances to a less toxic or non-toxic state. Microorganisms, they utilize the environment polluting organic compounds as food substrate. After the degradation of polluting compounds, the population of microorganism reduces in this environment. The goal of bioremediation is the neutralization of organic pollution to achieve undetectable concentration or concentration permissible by the regulations of particular places. During the utilization of bioremediation for the purpose of pollution neutralization, the following conditions must be met. The environment undergoing bioremediation should contain microorganisms characterized by specific catabolic processes. The microorganisms utilized within the bioremediation process should be capable of efficiently converting chemical compounds and reducing their concentration down to the level allowable by the regulation. The metabolites produced during biodegradation cannot have toxic, mutagenic, or carcinogenic properties. The conditions in the immediate area where the process is being conducted should be favorable to the growth and activity of the microorganisms. There should be adequate nutrients, acceptable pH, oxygen or other electron acceptors, acceptable redox potential, favorable moisture. The rate of biodegradation can be limited by temperature, the toxicity of concentrated contaminants, or mass transfer limitations. Now we'll discuss the choice of microbial strains capable of being used for the inoculation of contaminated grounds. Apart from the high efficiency of xenobiotic decomposition, the chosen strains should also possess many additional features that enable their adaptation and development in a new environment. And out of this, the another one condition is that the adaptation of inoculants in soil, and there should be a lack of antagonistic interactions with the natural water and soil microflora. Moreover, there cannot be pathogenic or ones which during the growth on hydrocarbons produces substances with cytotoxic, mutagenic or carcinogenic properties. Now we will discuss various bioremediation strategies. The division of bioremediation methods may be done in accordance with the level of environment oxygenation as well as the location of the cleaning process. And these bioremediation strategies can be classified into in situ and ex situ methods. First, we will discuss about the in situ methods. In situ methods of bioremediation are based mainly on the biostimulation of the organic pollutant degradation process by enriching the water and soils in biogenic elements, by acidity correction, as well as by aeration. We will discuss certain types of in situ methods. Among this, the most common method is the agricultural method. They are the most commonly used methods of soil decontamination. They are effective with almost all components of fuels. Usually, it is used for the elimination of hydrocarbons. And the simplest version of these agricultural methods that it depends upon the spreading of contaminated soil in a thin layer of no more than 0.5 meter thick, followed by a period of plowing or deep harrowing in order to aerate the soil. This activates the microflora by delivering essential nutrients, oxygenating the soil, and by deacidification when needed. Nutrients are replenished by application of nitrogenous, phosphate, or potassium fertilizers when necessary. Soil deacidification can be accomplished by liming process. Planting grasses or papillonaceous plants on the contaminated grounds may also assist the cleaning process. Another in situ method of bioremediation is known as bioextraction. Here, we will deliver the missing nutrients, supply oxygen if necessary, and we inoculate the soil with microorganisms able to actively decompose the contaminants. The processes of soil venting or aeration and rinsing with solution containing nutrients or active bacterial cultures are utilized. For this, we require technical equipments for the suction and positive displacement pumps and screens preventing the spreading of contaminants in the soil. Now we will discuss water stimulated bioremediation process which comes in the in situ methods. The goal of the above process is to force a vertical and then horizontal flow of water along with the organic contaminants in the soil and soil environment. This method is utilized for cleaning of the environment from petroleum-related non-soluble substances gathered at the surface of groundwater. During the process, the groundwater is pumped out up to the surface, purified, oxygenated, and returned back to the source after nutrient enrichment. Here is the diagrammatic representation of a water-stimulated biodegradation process. Here, in this process, we can see the groundwater is pumped out up to the surface and it is then oxygenated and returned back to the surface by using suction pumps. Another method of in situ bioremediation is bioventilation. Here, the acceleration of natural process of biodegradation may be assisted by soil ventilation. Ventilation is a physical method which may be utilized as an independent decontamination technique used for the maximization of volatilization of low molecular mass hydrocarbons like gasolines. The ventilation process permits the removal of volatile petroleum products from the aeration and saturation zones, at the same time enriching the ground with air and increasing the level of oxygenation. This is a diagrammatic representation of a bioventilation process. Here you can see that the aeration process can be both active and passive. In the case of passive ventilation, the aeration is done by utilization of perforated pipe networks. Active ventilation, however, depends upon the creation of a negative pressure, that is extraction of the ground air, or a positive pressure by using air injection. Now we will discuss the ex situ methods for bioremediation. Ex situ methods can be implemented when the danger of toxic pollutant migration into the groundwaters occurs and when the process of detoxification has to be completed in a short period of time. Here we use special bioreactors for bioremediation approaches. Here is a schematic diagram of a bioreactor method. They provide effective control of all the parameters, delivery of required ingredients, oxygenation, and inoculation of the soil. The cost of this method is, however, very high due to the technological requirements as well as the need for transportation of heavy masses. Therefore, the above method is often not used commonly and for smaller amount of soil. Thank you. Now we will discuss another approach of bioremediation process known as phytoremediation. Phytoremediation, or the use of plants to stimulate the degradation or the biotransformation or the removal of compounds either directly or in conjunction with microorganisms. A plant provides nutrients that allow co-metabolism to occur in the plant root zone or rhizosphere. The phytoremediation also include plant contributors to the degradation, immobilization, and involatilization. So with that, we finish the different bioremediation strategies. Thank you.